Welcome to episode 119 today of Yugabyte Friday Tech Talks, talks for engineers by engineers. My name is Alan Caldera. I'm a distinguished engineer here with Yugabyte. I'm joined today by my colleague Amit Chauhan, who is another sales engineer here with Yugabyte. Been here for a couple of years. And today's topic is building real-time data pipelines with Amazon Kinesis and Yugabyte DB. Take it away, Amit.
Thank you, Alan. Hi, guys. My name is Amit Chauhan. I'm a principal pre-sales engineer at Yugabyte, and have been here more than 2.5 years now. And today we are going to talk about building real-time data pipelines with Amazon Kinesis and Yugabyte DB. So let's just get started on that. So agenda, today we will talk about, as I mentioned, about Kinesis data stream and Yugabyte DB, but this talk track kind of applies not just to Kinesis. You can use the same content which we are going to build today with other streaming solutions like Google PubSub or Kafka, Red Panda, etc. So what we are going to do is introduce some basic concepts on these two technologies. What are the benefits of integrating them? And then we will do a small demo by creating a data pipeline which will have some dummy real store spread across the United States, and the data will stream to Kinesis. From Kinesis, it will come to Yugabyte DB, and then we have built a small app which we are going to demo, which will show the visualization as the data is streaming to our Yugabyte DB database. And let's before I go in there, I want to highlight a couple of things. That, as you know, Yugabyte DB is 100% open source database, but we do have multiple ways you can use it. So we have this database as a service, what we call Yugabyte DB Aeon, and we are going to, for today's demo purpose, we are going to use that. We'll quickly spin a new 3-node cluster in certain region with a across 3 availability zone in AWS, and after that, we will go and to AWS Kinesis data stream. We'll create one data stream and start our processes which will produce the data, and the listener which will consume the data, put it in Yugabyte DB, and finally there will be one small Spring Boot app which will provide this UI for visualization purposes. So it will show some metrics like this, what you see on your screen right now, and we will share the code also. So I have already made this code public, so I'm going to share that link also, where you can go and download this jar file and use it to get started rather quickly. So let's get some basics out of the way first. So what is real-time data processing? So I think of it as a continuous input, processing, and output of data immediately as it is produced or received from other systems. Idea here is the minimal latency between data production and processing to enable immediate decision making. And if I talk about importance in today's data, how does it fit in? So it enables businesses to react instantly to critical information. It is essential in scenarios where time is a crunch. Think fraud detection, like financial trading, and emergency response systems. Coming to some examples of real-time data applications, there are plenty, but think like online advertising, where you need the instant analysis of user data to serve the targeted ads. Internet of Things, like these IoT devices produce humongous amount of data. So immediate processing of the data to monitor the systems in near real time and resolve any issues as they occur. Finally, the benefits for companies, it provides the improved operational efficiency enhanced customer experience through personalized and timely interactions, and increased ability to capitalize on opportunities or mitigate risk as they arise. So with that, like we'll go to Amazon Kinesis and introduce it on the right side. You will see this nice architecture. But let me go back to very basics. What is Amazon Kinesis? So Amazon Kinesis is a platform on AWS. It is designed to collect, process, and analyze real-time data streams. So it enables developers like you and I to build applications capable of processing large streams of data in near real time. So there are three core components of Kinesis: Kinesis Data Stream, uh, Kinesis Data Firehouse, and then finally Kinesis Data Analytics. For today's talk, we are going to focus on Kinesis Data Stream. So the purpose of this is to capture, store, and process data streams from multiple sources, and we'll take this and build the demo around it today. So if you look at this architecture diagram, then the data will be flowing from a producer. It will go to Kinesis stream, and from that I will have a Kinesis listener, which will listen to this stream and put the data in our Yuga by DB. So briefly, we'll talk about key features and benefits. Uh, Scalability, like you can automatically scale to match the volume and throughput of the data. So you don't have to worry about that aspect, like what your data volume increases. Then durability and reliability. So data is replicated across multiple AWS availability zones to ensure high availability and data integrity. And finally, it's real time. I should say near real time, because it allows for near real time data processing and reducing the time when we can derive the insights from this data streams. Again, use cases, real-time analytics, dynamic data loading, and like very highly responsive applications you can build around it. So now coming to Yuga by DB, I want to talk a little bit about like people who might be not very familiar with Yuga by DB. So it's a modern database for transactional application that can run on any private, public, or hybrid cloud. So you get, if you look at the right side of my diagram, you will get asset transaction, horizontal scalability, and high availability out of box. So let's, and if you look at the architecture on of Yuga by DB, so you will notice that there are two layers here. And what happens is application will interact directly with this top query layer. Um, and, uh, and we have designed it with extensibility in mind. So currently we support YSQL and YSQL. So think of YSQL as a Postgres compatible API, and YSQL as it is a Cassandra compatible API. So if your existing app running on Postgres or YSQL, it's like a plug and play type thing. Bottom layer is where the whole magic happens. DocDB storage layer, where this is, think of it as a distributed document store. And this layer is responsible for a strong write consistency, extreme resilience to failures, automatic sharding, load balancing, etc. Basically, it's a shared nothing architecture. So this ensures that shards do not get bottlenecked by compute, storage, and networking resources available at single node. So you can horizontally scale your stuff. And as I mentioned, the best thing is that Yugabyte can be deployed anywhere, on any cloud, on-prem, using Kubernetes. And we do have like our Yugabyte DB, on which is a database as a service, which I'm going to briefly walk you through when I start my demo. So in nutshell, Yugabyte is Postgres SQL that scales, and it never fails. I want to spend a couple of minutes on this slide and want to show you the art of possible. So as I mentioned, that it's a shared nothing architecture, right? So you can deploy it in multiple fashions. So you can have like a single region, multi-zone type deployment, where if you need uh, resilience at a zone level, meaning like one of your zone goes down and you are still up and running. And you also want a low latency. This might be one way to go about it. But if your app requires like a resilience against even a regional failure, then you can spread your cluster in this diagram like number 2, where you can have cluster stretched across multiple regions and still attain like a very RP of 0 and RT of about 3 seconds or so for entire region failure. Finally, multi-cloud, multi-region type setup. And I'm saying cloud here, but it can be one of this can be your on-prem. As you can stretch your cluster between your on-premises and any multiple clouds per se. So it is cloud, as you can see, it's like cloud agnostic type solution. One final thing, like there is another way to do this topology is that you can have 2 different clusters running across different regions, and you can have asynchronous replication going between these 2 clusters. So people coming from traditional like production DR type environment, this is one layout like which will look very, very similar. So this is our own inbuilt solution, what we call X cluster, and it's think of it like if you are thinking like if you're familiar with Golden Gate, it's similar sort of like a AC replication. It can be bidirectional, it can be unidirectional. So I will talk a little bit about integrating Kinesis data streams with Yuga by DB and talk a little bit of seamless. So why we are doing it, like like we want to have a seamless data flow. And so data can originate from various sources, as I mentioned, like it can be IoT devices, apps, etc., producing this data. And Amazon Kinesis data stream will capture this continuous influx of data, and it will provide you with the real-time data processing capabilities. And finally, the processed data is then streamed efficiently into Yuga by DB, where we will store it and we'll do the real-time queries and analysis on this data from our system of record in Yuga by DB. So what are key benefits? Like why do I do that? Like so main advantage is scalability. So both platforms, like they excel in handling large scale data operations seamlessly. Kinesis can manage thousands of data streams concurrently, while Yuga by DB can scale horizontally to handle increased load. So you can keep throwing more and more data at it as your website or your app gets popular, and these two applications, Kinesis and Yuga by DB, they will keep up with the data, increased data volume. So you can easily scale out your clusters without having to touch your application. And when you can get like a real-time performance. So this integration, it facilitates immediate data availability in Yuga by DB after processing in Kinesis. So it is sort of essential for scenarios required where you need to do rapid decision making. And finally, and most importantly, I think about as a reliability and durability which you get out of it. So Yuga by DB, as I was showing in other screens, that it can tolerate zone region failures, and coupled with Kinesis's robust data stream management, you can minimize the data loss and downtime. And lastly, before I go to the next slide, the thing I wanted to mention is that they are both available as SaaS offering, and getting started is really quick. Like you can have a whole production pipeline going in matter of days. So let's spend a couple of minutes here talking about the architecture of this demo app which we have built. So there is, I'm going to call it Yuga Sales Dashboard. And imagine there are like number of retail store which are spread across the United States. Sales data is captured by each retail store, and and it streams to Kinesis data stream. So the data gets produced in the store. It is put in this data stream. Then what we'll have is that we'll do for simulating this retail store behavior. We have created one small Python script with the fake data, and I'm going to walk you through that also when I start my demo. So it will produce the data, it will put it in the data stream, and then I will have this small Java process Kinesis listener, which is watching this data stream. So it is going to look at the data, is uh, process it, and it's going to go put it in the Yuga DB Eon cluster. So for this demo, I have, as I mentioned, I have one 3-node cluster running in Virginia, US East one. And so all the data will go there. And then finally, we have built on the right side, you will see there is this orange icon, Spring Boot app. So what this will do is like it will, we have written 5-6 different REST API endpoints, which will make the call to our Yugabyte database cluster, pull the data, and then customers will be able to go to this machine and pull this information and see the visualization as the data is pouring in. And we'll do it all live. Just very high level, like data producer wise, what we are doing here is this Python script I mentioned. I'm generating some fake data in here. This is all available in that public GitHub I'm going to share. So I'm going to produce some data, and if you look at this bottom send data to Kinesis method, that's all I need to do. Like I have initialized my Kinesis stream, and I'm going to just put the record in there. So it's very simplistic way, and I can go in the detail in that on that too. So second process which I mentioned, which will consume the data from this stream. So I have this one Kinesis listener. It's a Java process. So it will listen to the stream. It will get that data, and then it will process it, and it will put it in Yugabyte cluster. So, and finally, this is the dashboard we are going to look at. So let's jump into to our to demo first. So very first thing I want to show is when you want to go create a data stream, you log into your account, you go your AWS account, you go to Amazon Kinesis, you create a data stream. So I have already created one, which I'm going to use, but it's very intuitive in nature. Like with few clicks, you can literally create this data stream in a matter of minutes. And this is the one which AM Chauhan demo one, which I have created, which I'm going to use it for our purpose right now. As you can see, it is active. Coming to our Yugabyte Eon offering. So if you go to cloud.yugabyte.com, you can log in, you can sign up for this service. It's available. There is a free tier cluster available as well, which you can try. And then what you do is typically what I have done is, since it's in AWS, I have already done a VPC pairing between my database VPC and my application VPC. So it's pretty straightforward. Like if you go, it's very intuitive. Like you go and you can choose the cloud you want to create it in. Of course, like we are using Kinesis, so we are going to do AWS in here, and there is and then I just go to next here. What I want to do is a single region deployment. You can also, if you want resiliency across multiple regions, you can do that too. So I will show you real quick here. Like I choose my region, which is North Virginia. I choose my number of CPUs I want. Since I already have a VPC pairing done, like I will use my VPC here. and then add my VPC peer networks for the allow list, and that's essentially it actually. So I go it and I can uh, download my credentials here and create cluster. It will take 5-10 minutes and it will create the cluster. I'm not going to create a new one, but wanted to show you the steps around it. So I will cancel out of it. And this is the one which I have already created, YFTT demo. As you can see right now, it doesn't have anything. It is not showing any read write. 3-node standard cluster is spread across a single region, 3 different zones. So now let's go back. Let's go to our terminal, and right now this is the public IP of the where my app server will run. As you can see right now, it's down. We are going to go start it. But before I do that, so I have already, like in that cluster, I have already created this table where the data will stream in. I call it uh, uh, YB sales. And if you look at it, it's standard stuff like sale ID, item ID, quantity, sale time, etc. Right, like the product name, category, and the state code, which we are going to use for some visualization here. I'm going to clear it. There is nothing right now here in that table. I've already truncated it, and uh, and this app. One thing which I wanted to show is like it's. I will share my GitHub link also. So there is, if you go to this GitHub link, like you will find all the source code which I was showing earlier. Like for example, like if for that data producing stuff, this is the Python script, the complete Python script you can download here, and other stuff like listener. So there will be a small service called Kinesis Stream Listener, which listens to this stream. And it's to easiest way to get started with this will be to just go to the releases and download this Kinesis jar. All you need is like a Java 17 on your machine, and you can start the process like this. You can pass these parameters to provide your node, your DB credentials, and just plug in this Kinesis jar and start the process. So now I'm going to, what I will do is I will go to the terminal. I have this Kinesis jar which I downloaded it, and that app has nothing but like a Java command for that. So I will start it up, and what it will do is it will make the connection to my that database cluster which I have created. And going back to my, if I go to my application now and refresh it, so you will see that that this is my application. It's not showing anything, of course, except this topology diagram. So this is the cluster I'm connected to. It will show you the region, US East 1, and then 1A, 1B, 1C, the zone, and then of course these 3 nodes. So you can scale your cluster and you can see all the diagram automatically repopulate in here. And let's go and maybe now produce some data. That the Python script which I was showing you earlier. So I have it in here. Python produce data. So I'm going to start running it, and you can see as it starts running, it creates this fake data, and it has started ingesting all this. Start putting in the data in the data stream, and it's showing you the shard ID and everything. And now if I go back to my application, since I had a listener running on the app, so you will notice that it's periodically going and pulling the data from that stream and putting it in the database. Of course, I have these 4 or 5 REST API endpoints. So if I go back to my application, you will see the data starts populating in on this in here. And visualization purpose, what I'm showing is like this cloud world is nothing but the state codes which we're showing. So if we go back to um, our table where we are populating the data, so I will quickly show you some limit 10. So some sample data like showing the sales ID, which is nothing but like a UUID, random UUID, item number, timing, and store, which it belongs to the sale price, and there's a state code you might see. So like Illinois, Delaware, Tennessee, etc. And these are all. So what this visualization is in a way showing, like which state is having the most sales, right now. Like it looks like Colorado is making the most sales, or maybe and the ME. So it is of course the random stuff, right? Like over last couple of hours, or this is very very smallish data. And you will notice that there is a this total sales with the number of records which it has come in. I'm kind of right now uh, uh, throwing only very small data when I'm producing at it. So that's why you will see it incrementally every 10 seconds at a slow rate. But we can easily go and make the change in the producer to speed it up. And the other thing is like this, how your categories are doing. So it will kind of highlight that how much sales amount per minute for last couple of hours. Like this chart, I think I'm pulling for last 4 hours, but since I just truncated the table and started it, it will show you this. Then of course the sale distribution. I really like to see this box chart visualization where you can see what is your maximum sale, and as you can see, it's less than 1,000 because that random value which I have probably $1,000. That's why you see the maximum is less than that, and then the upper quartile and lower quartile and minimum sale, all that good stuff. So this is my presentation and this concludes my demo. Any questions around it? Would love to take that. Yeah, and again, like you can visit this. Let me go and if you want to take the picture of it, we have you can, if you have any questions on this, you can join our community Slack channel. I'm present there and ask any questions around it. You can go star our, as I mentioned, Yugabyte DB is like an 100% open source database. So you can go and check out the Yugabyte DB code. And of course that this demo app is available on in this public URL. So everything which I showed you I built is available in here. You can feel free to play with it. And concluding remark, one thing I would mention is that although this demo focused on Kinesis and Yugabyte DB, but you can, and this is something which in the same repository I'm going to go and do, is like add other stuff as well in there. Like you can, if you want to stream the data from Red Panda, from GCP, PubSub, or Kafka, or Pulsar. So you can easily build those that similar stuff. It's very very easy to get started, especially with the managed service. And so, Alan, if there are no questions, I think this concludes my presentation.
Okay. Thanks a lot, Amit. That was very informative. I don't see any questions on the channel, and I don't. Okay, so actually, there is one that just came in. When would I want to do this versus using CDC?
So this is more of like ingestion stuff, right? Like so, CDC comes into play when you have data, let's say in Yugabyte DB, right? And you want to do whatever the changes are occurring within the database. You want to build that pipeline. So you will be using CDC for that purpose. This one will be more of the way I have used streaming in my past is like, I will give you one real example. I built this this application called RTT at Realtime Tools, where anything like when the cell connects to the network, wireless network, it used to form a row of record. So this was all put in. This data will stream to Apache Pulsar, and I will go ingest the data from Pulsar and put it in my database. That time I was using Apache to it for that purpose. So it will come into play from that purpose. Like if you want to ingest like humongous amount of data in near real time, and then process it and then store it as a system of records, this comes into play.
Yeah. Yeah, I just wanted to point out as well that, in the case of CDC, this would, from CDC perspective, it would be more of an application, a live application. So if the stores were actually making live updates via, either asynchronous replication, or if they were using a cloud app and then you wanted to stream this out in the dashboard, then we would use CDC to feed Kinesis to build this type of dashboard.
Yeah, excellent. And one other advantage which I should highlight here is that if you put the data in the Kinesis, then like you can do multiple things with it. Not just Kinesis, like in Kafka, Pulsar, or anywhere, right? Like there can be a pipeline which might be flowing to your system of record. There might be a pipeline which might be flowing to your data lake solution. So the same data, like you publish one at one place, and then you consume it from multiple places. So that's another advantage of doing the streaming.
Yeah. Okay. We're at our time for today. Thank you all for joining. This concludes episode 119 of YFTT Friday Tech Talks by engineers for engineers.